Good morning. Please switch camera.
Good morning, everyone. Trust your attendance has already been captured, so we can
Good
start.
morning, sir.
Good morning, good morning,
Good morning, sir.
good morning.
Good morning, sir.
Righto, righto, good morning. Okay, so as per our plan already discussed, we can have a small talk about draft survey. And you see, I think recording has started. That is good. Yeah, right. So, by any chance, did you go through that chapter I had told you? Go through it, which is this one. 1 minute. This one. Did you manage to go through this chapter?
Yes, sir.
Okay. The whole point is to calculate the vessel's displacement, which may be after loading or could be after discharging. What is the net displacement after this? When you have carried out the cargo operation. Then you subtract all the variables from it and you get cargo quantity. That is the general idea. But this is not like stability. In draft survey, there are many factors which you take into account to come to an accurate conclusion, which we are going to consider. Draft survey per se is not any physical science, it is just a series of corrections you apply to get to a displacement, corrected displacement. That is the idea. Some formulas which you will use, which have been used and have been used for a long time, proven correct, or at least approved by draft surveyors also. So those formulas we will correlate, we will come to conclusion, we are going to write them down and then use them in any draft survey question. For this particular thing, we are going to, as you can see on the shared screen, we are going to do the draft surveys chapter from Hinchip, which is the one which is open. Draft surveys chapter from MB Hinchip. And primary reason is because this will involve the use of Hinchip particulars also. So please keep it handy, the book as well as the particulars. But it is still some time to go. You can arrange easily because first we will just have a look at what is it all about before we go to the questions. Questions in this book start from 105. Question number 105 is the first question, and thereafter the questions continue up till 108 or 109. Okay. Just to start our discussion, let us hypothetically assume we are looking at a arrival load port for any vessel. Arrival load port. Arrival load port in any vessel, any load port, but we are looking at a scenario where the vessel has arrived at load port. So in this case, let us say there is cargo. If we say it is nil because this is the first arrival port, so cargo we can say is zero, 0 metric ton. And definitely you will have ballast because it is arrival load port, so you take ballast x tons or whatever ballast for arrival, we can say is equal to so many tons, metric tons ballast. Then you could have what is called fresh water on board, which is also contributing towards displacement. What I mean to say is we are looking at factors which are contributing towards displacement, which you intend to calculate. Then what else could you have? Of course, you can have fuel oil, which could be anything. I'm just writing one word only, fuel oil, which could include HFO, diesel oil, etc. Fuel oil, and I will put it as F. Then, just to separate it out, I say we got lube oil, not included in fuel oil, lube oil, so many metric tons. Anything else which is contributing to displacement, arrival load port? Anji, can you think of something else which is contributing towards the displacement, arrival load port?
Constant.
1 minute. Constant will come later. Let us say light displacement possible. Right now, you have drafts. You have observed the drafts. Of course, they need to be corrected. That is coming. We are going to discuss that. But drafts you have read. So once you have read the drafts, you can come to a conclusion. How much is the displacement, present displacement from the drafts? You go back to hydrostatic particulars, and then you can find out your displacement at this particular draft, which is hydrostatic draft. You remember, headship tabulation is done for hydrostatic draft. So you can easily find out your displacement by the adding up all this. Anybody saying something? You are requested to keep yourself muted, please. We have started our discussion. You can unmute and talk. Right. So if you add up all this, you can find the displacement W from your drafts tabulated. You read hydrostatic particulars and the W you can find out, right? But since somebody had mentioned, maybe this will not match. It will not match because this does not include what is called the constant, which is a yearly basis or added on weight for anti-fouling barnacles on the ship side, demucking not done in the DB tanks, etc. That is contributing to constant. So this may not match. You have found out the W by adding up all the weights which are contributing towards W, but what you have missed out is the constant. So if there is something which is missing from here, that will contribute and that will be called constant. So this will be also a factor which will contribute towards the arrival load port displacement. Although you are not aware, but you can find out by knowing, by adding up all the known weights, if it is not matching with the W which you are finding from the hydrostatic particular, then what is remaining is called constant. Of course, it cannot be a very large quantity depending on the age of the vessel. Normally, the constant could be something like 300, 350, something like that for a bulk carrier, handy size bulk carrier. But it will be there. So that is arrival load port. So this is one draft survey which will lead you to the arrival load port W. Right. Now let us see in the same port, I mean in the other port, the discharge port. You carry out another draft survey in the discharge port. Now here, let us say you don't know, you have not yet got the figures, you don't know what is the cargo, how much the cargo is discharged. And this is your intention to find out how much cargo was discharged. You have at the load port taken out some ballast, but you are aware how much the ballast remaining. So that can also factor in. You can write ballast also at the discharge port. Now you might have taken in fresh water, you might have used fresh water, but still you can find out what is the fresh water quantity at the discharge port, present fresh water. You might have bunkered fuel oil, you might have used some fuel oil in the port state, so this can be taken as, or during the voyage, this can be taken as fuel oil present at the discharge port. How much is it? Same thing for lube oil, present lube oil. Luckily, light displacement will remain same. Now, again at the discharge port, you have taken the drafts, you have read the draft, observed draft. From the observed drafts, you read out from your hydrostatic particulars what is the W, present W at arrival discharge port. ये इसमें एक लाइन इतनी जरूरी है कि you can write arrival. You are not yet discharged. Arrival discharge port. So, if you add up all this, which is ballast plus fresh water oil, lube oil, and light displacement, you should reach what is called the discharge port arrival displacement.
सर इसमें कार्गो ऐड नहीं होगा क्या?
Yes. That is the point. I was waiting for it. You're absolutely right. The thing is that if you add up all this, what we have listed out, then you reach a displacement, but this displacement is minus the cargo, right? तो आपने अराइवल डिस्चार्ज पोर्ट पे W निकाल लिया, डिस्चार्ज पोर्ट को अलग करने के लिए मैंने इसको WD लिख दिया, displacement on arrival discharge port. You can get it from your draft. How much is the displacement now? But when you calculate all this, when you add up everything, you will not reach this displacement because cargo is still to come. So obviously, इसका जो summation है, the summation of this, all this will give you net. I'm just using the word net. It does not mean anything. Net W arrival discharge port minus right. When you add up all this, you can reach the net W summation arrival discharge port minus cargo. So whatever is remaining from your draft, which you have calculated, read the drafts, observed drafts, you have taken from the hydrostatic particulars, you know what is the W now, but this is without cargo. So whatever is the difference is contributing towards cargo. That is one thing. Secondly, इसमें अगर आप नोट करोगे, constant अभी फिकर नहीं किया हमने. So actually speaking, this net W will be, if I can write it like this, it will be more correct. We say cargo plus constant, right? What do you say now? Yeah, you agree to this one, Abhitat? Now the thing is that if you have been able to calculate arrival load port to constant, then it is not going to change from the point of constant at arrival load port and discharge port. That constant will be same. If you have figured it out, which you have to figure out anyway, then this constant is to be subtracted and you will get only cargo, which is your intention. That is what you wanted to do. You wanted to find out how much cargo discharged at the discharge port. Now to arrive at the W or WD by draft survey involves steps. Steps which are incorporated in the draft survey. Then you use those steps to calculate the arrival load port W, and also at discharge port you do a draft survey to calculate WD. D is only to indicate it is a discharge port W. So steps you use both times at the load port and discharge port. Calculate your W, and if you have already done the constant, then cargo plus constant is this. So subtract the constant if you are knowing that, and you get only cargo, which is your intention.
सर इस पे न्यूमेरिकल नहीं करेंगे?
अरे 100% न्यूमेरिकली तो आएगा, पर सीधे न्यूमेरिकल नहीं. Let us first have a little understanding, because really speaking, it is only a method of following principles, or not principles, the method of following formulae which have been proven correct for so many years. We will try and see if we can also find some explanation for the formulas, but mostly it is a adjust method that this is a formula to be used, but that numerical will come later on. I mean, इसी discussion में numerical figure करेगा, but we can't go straight to numerical. We need to just have a small view of the theory behind it, right? आपके क्वेश्चन पेपर में न्यूमेरिकल ही आता है. If you have gone through the past question papers, तो न्यूमेरिकल ही आता है. It could be question number 2 or could be question number 3, or it could be sometimes 1 also, but there will be a tanker numerical and also this numerical on draft survey. So that is there. Numerical तो करना ही है. Now, just a minute, let me share the screen. It is something like this. To put it across very simply, I'm sure you have seen weighbridges. weighbridge देखे? weighbridge जिसमें ट्रक का वेट लोड फाइंड आउट हो सकता है. weighbridge, right? So what does it do? You put the truck on the weighbridge and you see how much is the truck weighing. इसमें से अगर तुम ट्रक का वेट निकाल लो, if you take out the weight of the truck itself, air weight of the truck, then what you have is the cargo on truck. But now, as far as the ship is concerned, you can't put the ship on the weighbridge. You will have to calculate using drafts. That is the fundamental of draft survey. Principle is same, but here you can read out the weight of the truck and loaded weight on the beverage, but for a ship you will need to calculate using steps 1 2 3 4 like this. Steps you will follow in every question to come to the conclusion that how much is the cargo loaded, discharged or on board right now. अच्छा एक बात बताओ, just as discussion, where do you use draft survey? Do you use it on tankers?
सर टैंकर पे तो नहीं होता है,
बल्क कैरियर पे तो होता है सर।
बल्क कैरियर पे ही होता है।
Ajay, sorry,
Sir, on bulk carriers.
right, but on tankers?
टैंकर पे किसी कार्गो पे होता है सर।
Sometimes on tanker also.
सर पे सर देखा
Bulk
नहीं है
carrier always.
होता हुआ नहीं देखा सर कभी।
ओके ओके, पर ठीक है, चलो मैं आपकी बात मानता हूँ। Tankers with this is normally not done, although it is left to the prerogative of the shipper, charterer and the ship owner. If they want to do it, they can do it. But let us start by saying that tankers with this is not really a practice followed. Bulk carrier will follow only. Now, can you think why it is not done on tanker? Any reason?
because sir, we know the density of cargo and volume of our tank.
एक मिनट, you know the density of cargo I followed. उसके आगे?
Volume of our tanks.
Yeah, very good. Yeah. And then you can find the weight of the cargo loaded.
Yes sir.
Okay. You know the volume. Density is tons per metric cube, and you know the volume. दोनों को तुमने multiply किया, you are left out with only tons.
PCF correction, WCF correction लगा के
देखो,
find out.
correction तो लगेंगे, ठीक है, correction तो लगेंगे, but basically you are not doing the draft survey thing because you know the volume of the tank and you also know the density of the cargo you are loading after all the corrections, maybe temperature, etc. But you can find out the tons loaded. So how does this differ from bulk carrier? Bulk carrier में आपके पास density है cargo की?
But sir,
हाँ,
different type के cargo है ना
सर जो
सर,
settle होते हैं सर.
अलग अलग डेंसिटी है, किसी का स्टोरेज फैक्टर ज्यादा है, किसी का कम है।
क्या चीज?
सर बल्क कैरियर में ब्रोकन स्टोरेज रहता है और उसमें नहीं
Yes,
रहता
बिल्कुल,
स्पेसेस।
correct. That's the point. That is the point. Bulk carrier में involvement आ जाएगी broken storage की. So even if you know the volume of the hold, yes, you will know the volume of the hold. The point is that you cannot just simply multiply by the density of the cargo being loaded because there is broken storage involved, which you cannot just assimilate like that. So the best method will be to use this principle of draft survey on bulk carriers, where you do it once when you arrive load port, then loaded cargo, and then you do it before departure. So you know how much cargo has been loaded, and this will take into account everything, broken storage, etc. Everything will be correlated. This is the reason. This is the principal reason why it is followed on bulk carriers. The method of draft survey. Anything else which will give you tons of cargo loaded on bulk carrier? ये तो है, ये तो एक तरीका है. Anything else which will tell you how much cargo you have loaded bulk carrier पे? What about the shore figure, which is, it may be having a weighing scale underneath the conveyor belt, which is bringing the cargo in. So it is continuously monitoring the loaded weight of the cargo using the weighing scale, of course, sophisticated ones, which are located on the conveyor belt itself, which is bringing in the cargo. Possible? Yes, that is one possibility. In matter of fact,
बहुत मुश्किल है सर, बट
बहुत मुश्किल है. क्या
तो
चीज
आप
मुश्किल है?
पता कि सर कन्वेयर बेल्ट में उन्होंने एक बार सामान लोड कर दिया, कन्वेयर बेल्ट लंबी है, कहाँ से कहाँ चल के आ रही है, उसमें
हाँ, हाँ.
कॉन्टिन्यूसली सामान लोड होता रहेगा और कन्वेयर बेल्ट में भी गिरता रहता होगा ना सर कार्गो, तो उसका तो वेट हर टाइम चेंज ही होता रहेगा बार बार।
नहीं, बात ऐसी है, ठीक कह रहे हैं आप, लेकिन अगर आप देखें कन्वेयर बेल्ट तो चल रही है वेयर हाउस से लेके और शायद के होल्ड तक, राइट? So पहले तुम लो, फिर आप अपनी आर्गुमेंट देना. कन्वेयर बेल्ट चल रही है, वेयर हाउस में कार्गो है, लेट अस से बल्क कार्गो है, लेट अस से फॉर एग्जांपल आयरन ओर है वेयर हाउस में, वहाँ से वो कन्वेयर बेल्ट के ऊपर डाला जा रहा है बाय एनी मीन्स, मे बी एक्सकेवेटर, मे बी यू नो ग्रैब ऑन द कन्वेयर बेल्ट. देन द कन्वेयर बेल्ट इज ट्रेवलिंग and reaching the loader arm which is located on top of the cargo on the ship. So in between the travel of the conveyor belt there could be some weighing scales located which are monitoring how much weight is passing over them, which is tabulated, which can be assimilated, which could be computerized also. But you can find out, and people do find out कि कितना cargo चला गया. But as this candidate has rightly pointed out, the issues are regarding loss of cargo while it is traveling on the conveyor belt by maybe even spillage that you don't know. उसने तो अपना काम कर दिया scale ने, but you don't know कि how much has been spilled as the cargo is being carried on to the road, right? That he is not taking into account. Now, the only method remaining will be to do a draft survey at the end of the whole thing, which means that you will now see just simply whether the cargo has been blown away by wind, whether it has been lost by spillage. At the end, how much has come in, you can find out by draft survey or bulk. And similarly, for this reason, you have clauses done on the master sheet, cargo said to be by shore figure and cargo determined by draft survey. Mention more. If there is a very large discrepancy difference, then you have to put a note of protest saying that this is not matching. Because for a handy size bulk carrier, let's say 15,000 ton loaded draft, summer draft way, TPC is something like 47-50 tons per centimeter. Okay. So when you are making a difference even of 2 centimeters, you are looking at a difference of 100 tons. That multiplied by the freight is going to be enormous. So it has to be done very carefully. Most of the charterers, most of the shippers, and most of the ship owners will insist on a draft survey. Not only that, not only they will insist on the draft survey and get it done, they will also have independent surveyors apart from chief officer who will carry out the survey. I think this must have been seen by people who have worked on bulk carriers, even though as second officer, they must have seen this. A surveyor coming, SGS surveyor coming at the load port or maybe discharge port, and then working with chief officer to find out these figures of cargo, etc. ये तो देखा होगा आपने. So that is the reason why it is done on the bulk carrier, and as I said, it is not a written law that tanker पे bulk carrier draft survey होगा ही नहीं, ये कहीं लिखा नहीं है. It is left to the owner's discretion and the charterer. They might do it on the tanker also. If they are having some issues, they can do it on tanker also. But mostly it is avoided for the very simple reason which you have pointed out कि उसका volume जो है cargo compartment का या tanker known है, और क्योंकि वो पूरा लोड हो रहा है, टॉप अप हो रहा है, तो ब्रोकन स्टोरेज का चांस नहीं.
सर
सो व्हाटएवर. हाँ जी प्लीज बोलिए.
फॉर एग्जांपल कि टैंकर पे मैंने देखा है, मतलब होता हुआ
अच्छा.
वो मोलेसिस कार्गो होता है ना सर, मोलेसिस,
हाँ 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 बिल्कुल.
वो जब लोड करते हैं तो उसमें हमने ड्राफ्ट सर्वे किया था सर.
Correct. So again, this proves what we are discussing. Okay, although not required, because we are knowing the volumes, although not required, it may be determined by draft survey also on a tanker itself by prerogative of the charterer or ship owner. कहीं रिटन लॉ नहीं है कि आपने टैंकर में करना ही नहीं है. अच्छा, एक बात और है. लेट अस से वी आर टॉकिंग ऑफ अ गैस कैरियर, वहाँ पे इशू आ सकता है. बिकॉज यू से इट इज लोडेड बट यू डोंट नो कि वहाँ पे पूरा जो कंपार्टमेंट है गैस कैरियर पे वो पूरा लोड हो गया कि नहीं. एवरी नूक एंड कॉर्नर पे क्या गैस पहुँच गया. सो इट मे बी डन देयर ऑल्सो फॉर अ ड्राफ्ट सर्वे. See, the thing is that what you're getting from the shore the means used to determine the cargo quantity from shore figures is the best. Normally, believe me, practically, you do the draft survey on bulk carriers, but the figure put on the bill of lading is the shore figure, despite the fact that there may be small difference. Still, it is believed to be the shore figure which is correct. That is something. But if there is a large difference, then you have to put a remark. You have to put a remark, which is very simple. You write one line: cargo loaded determined by shore so many tons. Then second line: cargo determined by draft survey is equal to so many tons. Difference so many tons. The vessel hence registers a note of protest for the difference in cargo quantity loaded from shore and shipyards. ये लग जाती है bill of lading में, right? So that is the thing regarding draft survey. So very simply, first the initial weight, displacement W of the vessel, and the final weight W after the ship has been loaded. Difference between the weights will be the cargo loaded. Very simply, the difference between the weights in both arrival, initial and final will tell you how much cargo has been loaded. But the thing is that you will have to incorporate everything, which means what was the ballast when you arrived, what is the ballast now when you are sailing out after loading, what was the fuel oil before loading, what is the fuel oil now. Just as we saw in this example, this has to be done. You cannot simply subtract the W's. This has to be done. You have to take into account all and constant. Very important. So suppose you are a chief officer who has just joined this vessel, a bulk carrier you joined as chief officer. Now, in the records of this bulk carrier, you will find from previous chief officers who have calculated constant. But for good order's sake, what you should do is, for the first time when you do this on board this vessel, which you have just now joined, you must work out constant yourself. And then maybe you can continue using it for your contract period of 6 months or so, because it will not change. But you must determine constant when you first calculate as you was. So this can be done like this. Arrival load port, you calculate your W. Calculate means you read out your W from your particulars, then include all the weights. This W should be matching with this one. But if there is a difference, that is constant, because that has not been accounted for. Right? A simple process, not complicated at all. Of course, now the thing is, since you are doing and calculating your arrival load port W, how to calculate it is by draft survey, which involves 5-6 steps. You will reach this definitely. You can also reach constant, but to calculate this arrival load port W by drafts, you will need to follow some steps, which is what our subject of discussion is, which is what numericals, so-called, are based. Okay. Basic principle of draft survey is very simply Archimedes principle. Before we go further, basic principle is Archimedes principle. And then of course you can continue using the Archimedes principle to find out before loading, displacement measured by draft survey, cargo zero is obviously, and all this is there. Stores, constant, and stores and constant could be one way, could be just one quantity, for which you say constant includes stores also. Or you can have, if you know, you can input stores separately and use constant separately, but mostly because stores are also a very heavy variable, stores and constant could be one quantity. And this we are talking about before loading. So you find out your initial displacement just as we saw in our spread word spreadsheet also. Find out fuel, lube oil, maybe lube oil plus heavy oil, diesel oil, etc. Maybe only one quantity, and fresh water. This is all including contributing towards this displacement. कार्गो जीरो होगा क्योंकि लोडिंग पोर्ट है, लोड पोर्ट है, क्या हम ट्रांसफर में कर रहे हैं बैलास्ट. एक चीज और है, what makes difference is the quantity of ballast. I hope you can see the share screen. So can you tell me कि ballast आप कैसे अकाउंट करेंगे on arrival load port ballast?
तो शेयर स्क्रीन नहीं आ रही.
शेयर स्क्रीन नहीं आ रही. Okay, one minute. Now,
अब आ रही.
हाँ सर आई अभी.
okay, very good. So I don't think you have missed out much. I was talking, and I think you followed it also. So initial weight, draft survey, final weight, draft survey. Difference of both telling you how much cargo has been loaded. We are looking at arrival load form. Right? This is the basic thing. But of course, so many corrections will be there. Now, before loading condition आ गया, cargo zero है और stores constant वगैरह सब आपने लगा दिया यहाँ पे. Any quantity, fuel could be one, consolidated one with diesel oil separate, heavy oil separate, lube oil separate. It could be like that also. And then we talk of ballast. Ballast, whatever it is. How will you come to a conclusion? Okay, arrival load port में तुम्हारा ballast इतना है. Arrival load port. अभी शुरू नहीं हुई loading. You have just arrived where you're carrying out the draft survey. Then you have to come to a conclusion how much ballast is there on board. So normally how you will do that? Come to this figure. कितना ballast है? Very simply by taking soundings, right? Applying the trim and list correction to the sounding table and getting the value, isn't it? But the thing is that this can also lead to an error. It will depend on how the sounding is being recorded. किसी ने जवाब नहीं दिया था. Can anybody tell me he was involved with draft survey as a duty officer working on board?
Yes, sir.
Anyone? You were involved, right?
Yes, sir.
While carrying out a draft survey on board?
Yes, sir.
Okay, very good. Chetan, tell me, ये soundings के लिए कौन जाता है?
I was a cadet in bulk carrier that time. I have done and in tankers one time. Just.
Okay, very good. Good experience. अब ये बताओ चेतन कि ये जो बैलेंस की फिगर हम कह रहे हैं ये तो ऐसे लिखा हुआ एग्जांपल के लिए, इसको हम कैसे अराइव करेंगे? टेकिंग साउंडिंग्स of the various tanks, right?
Yes, sir.
Right. जब आप ये कर रहे थे, did the surveyor, was there a surveyor appointed also? SGS surveyor also?
Yes, sir.
If you can remember.
Yeah, surveyor was there, sir.
There was a surveyor, right? So suppose it was you who was taking the sounding, just hypothetically assuming, did the surveyor accompany you?
Yes, sir.
He wants to see how you're taking the sounding.
Yes, sir.
Because this is a factor which contributes heavily to discrepancies, the quantity of balance.
Yes, sir.
This has to be done very carefully. Apart from the reading of the drafts, which we will talk, the reading of drafts is also important. But the calculation of ballast on board is only by soundings, and that can lead to discrepancies. So the surveyors will normally insist that they have to come with you. They are not going to let you go just like that. Very rarely a surveyor believes what you show him in your sounding book and he agrees to it. Very rarely. He would like to take soundings. Not only before loading, also after loading. When you say final, then also he will come with you. So one time he has gone around with you, taking the sounding, and then later on, after the finishing line has been sounded, then the vessel is completed loading, again he might come with you. Take final sounding. I think this is how it is done. This was done like this, and I'm sure people who have done it will agree with me. And of course, the final thing when you have change in displacement from arrival to departure, change in ballast, cargo loaded so much, but then this is just very, very hypothetical. Not only change in ballast, change in stores, change in fuel oil, that has not been accounted here. Change in fuel oil, may be used or may be bunkered. Change in fresh water. All this will also have to come here to come to a final figure that this is a net displacement now or change in displacement. And then you can find how much is the cargo load. वेरी वेरी सिंपली पुट इसी में शुरू होगा डिस्कशन अपना इट इज अभी शुरू हुआ है विल सी पहले एक हल्का सा रीड अबाउट द थ्योरी पार्ट राइट if you have the inclination I would recommend if you can go through that chapter again अगर आपने नहीं पढ़ा हुआ but we take a small Kit Kat we come back and meet at 10:15 to continue okay
Yes, sir. Thank you.
okay जी ब्रेक टाइम में प्लीज वो चैप्टर देख लेना Continue our discussion. Let us continue. We had talked about it. Why draft survey? And we also talked about this on tankers. Quantity loaded is simple. We know the density, we know the volume. So it is easy to calculate the weight of cargo loaded. But let us now come to a bulk cargo like coal. इसमें we cannot measure the weight by just measuring the height of the hole to which the cargo is loaded. Tanker, you are taking the sounding, you know how much has been loaded by volume and density of the cargo. But here, you cannot just measure height of the whole cargo which is loaded inside the hole, because unlike liquid, solid cargo will not take the shape of the hole or the shape of the cargo compartment. It is not going to engulf the shape. It is going to take its own shape, angle of the hole, etc. So for this reason, the quantity of cargo loaded with draft survey is the most appropriate way. Most appropriate. As we said, you would also have ring scales underneath the conveyor belts, but draft survey becomes very nice and important because this is the best method, draft survey. In fact, most of the charter parties insist on draft survey. It is mentioned in the charter party that initially there will be a draft survey on arrival and final draft survey will be there, which we had also talked. We'll talk more about it. You can introduce what is called an intermediate draft survey, just to be on the safer side, so that you know how the loading is progressing. Is the rate of loading which has been furnished by the terminal, is that being followed or not? For which you will have an intermediate draft survey incorporated into your load plan. As rightly remarked also, when we started our discussion, candidate has had experience, let us say on tanker. He has had draft survey and he has also had experience, which is very important. It is very prominent. Cargo molasses loaded in chemical tankers. Why is this so? Is also, important just as a cargo molasses, because the density of the cargo molasses is not uniform. The cargo has air in it. So you just cannot measure the height of the cargo loaded and multiply it by the density, etc. Volume is also incorporating the air contained in the cargo. So now you cannot just find simply by multiplying volume into density. Then you have to incorporate draft survey. And I think our candidate here had remarked his idea. Molasses he has loaded and he had carried out a draft survey. So just because if you employ the simple method, calculating weight of liquid for molasses, let us say, this is not uniform cargo, it has got air in it, density of cargo is not uniform, and then you will get a wrong quantity, which can give rise to a lot of claims. Wrong quantity means, as we said, TPC could be anything, 4750 tons per centimeter and summer draft, and freight could be anything. $800, $900 something, this will involve a lot of money. That is why a draft survey will become necessary in such cargoes. So this will remain the basic difference in arrival and difference in departure. The difference between two will give you how much is the cargo loaded. This is the basic principle. On arrival, you have this displacement, cargo is 0, load port की बात हो रही है, ballast is 600 tons, other weights 1000 टन ऑन डिपार्चर डिस्प्लेसमेंट कितनी है, कार्गो आपको पता नहीं है, यू आर कैलकुलेटिंग बैलेंस इतना है, अदर वेट्स which could include, let us say, constant fuel oil, etc. Other weights. Difference in displacement is 30,000. But let us say 5,500 tons of ballast was removed and some cargo was loaded in this port. Remember कि displacement का difference है 30,000. जिस example में, but 5,500 tons of ballast was removed. So how is this contributed upon? How can you account for this? From the W, see, 5,500 tons of ballast was removed or pumped out. So it has been replaced by cargo. So when you're calculating cargo loaded, this will contribute towards cargo because 5,500 tons of ballast has been removed. So this has been replaced. The tons will remain because it is the net displacement. This is substituted by cargo. So this will contribute towards cargo loaded. Plus, on the other hand, just to take it a step further, suppose 5,500 tons of ballast was pumped in, then that has to be subtracted from the cargo loaded because that is not contributing towards the weight of cargo. That will be subtracted, pumped in. But in this case, we say it has been pumped out, so this will contribute or has been contributed. The W has been contributed by cargo loading, so this will be added. Right? Go further. This one is simple. This plus this will give you cargo loaded. This one is relatively simple. Whether in the arrival load port or whether in discharge port or whether in the departure of load port, the principle is about calculating ship's displacement from the drafts for the carrying out of drafts only. Just calculating of W displacement from the drafts of the ship, for which you will see the steps and we will discuss about the steps, but that is the crux or zoom idea. We have talked about it. Note down the drafts, correct the drafts. Maybe you got a list A plus B plus divide by 2 ऐसा कर लो, both sides, starboard side plus 2 divide by 2. You get the mean drafts of list. Then once you have done that, you go back to your trim and stability booklet, calculate your W. Corrections have to be introduced, which is what we are going to look at. Draft of the vessel. Draft. अच्छा एक बात बताइए. What about the drafts of MV engine? Location of the draft marks for MV engine. Where are they painted? MV engine.
Aft.
Aft. I did not get it. Aft मतलब आप देखिए जरा particulars में. Draft marks as far as hinge ship is concerned are painted on the forward and aft perpendiculars. Hinge ship. It is not fact that it is painted always on perpendicular, hinge shape में perpendicular में है. ठीक है? It could be anywhere, displaced from the perpendiculars. But as far as hinge shape is concerned, draft marks are painted on the perpendiculars. From the particulars, just sharing with you, from the particulars, have a look at this. These are the particulars and the hinge shape. It is page number 2 actually of the publication. Have a look at this. Draft marks are to be assumed as at the 4.5 perpendicular. Hinge shape के लिए.
सर ये 6 वाला स्टेटमेंट सही लिखा हुआ है क्या?
6 वाला. ये GM fluid means GSM solid minus FS.
हाँ.
इसमें क्यों कंफ्यूजन है आपको? GM fluid. I could not follow. इसमें कंफ्यूजन क्यों हो रहा है?
तो ये प्लस नहीं होना चाहिए.
GM solid पे आप कैसे आएंगे? GM solid will be KM minus KG. Fluid is minus FSC. ये तो correct statement है. I did not get it. Why you should sound confused?
सर GM fluid कैसे आएंगे?
GM solid आप कैसे आएंगे? Let us एक मिनट. GM solid. KM minus KG.
हाँ.
हाँ तो फिर उसके बाद FSC निकाल दो तो तुम फ्लूइड पे पहुंच गए.
ठीक है सर.
To come back to what we were talking about, just I wanted to show you that as far as hinge shape is concerned, which is again you see just a mention, because as far as the draft survey numericals are concerned, draft marks are never at the perpendicular. In fact, you have to apply a correction to come to perpendiculars. But otherwise, as far as MV hinge shape is concerned, draft marks are supposed to be assumed to be painted at the perpendiculars, 4.5. But this is not the case for every shape. Draft marks are not painted at the perpendicular, they are painted somewhere else. You have a distance away from perpendiculars. चलो इसको देखते हैं. That is the first correction actually. When you start talking about drafts, this is the first correction. To correct the drafts which you have observed, to bring them back on the perpendiculars. That is the first correction introduced. चलो अच्छा, अब ये बात हो रही थी कि पहला तो आपने ये याद रखना है, as far as hinge shape is concerned, hinge chip, उसके लिए draft marks are assumed to be at the 4.5 to 20 plus. ठीक है, चलो let us proceed further. एक सेकंड, ये तो hinge chip की बात हो रही है. Some general definitions which you are well aware, but no harm just before we get into the draft survey actually. Displacement, I'm very sure you are aware what is W, displacement. Actual total weight expressed in metric tons normally, calculated by multiplying the volume of the hull below the waterline, which is the volume of water displaced, by density of the water. So this is actually W is always expressed as the underwater volume, UW volume multiplied by density in which he is floating. That will give you W or displacement. Dead weight, again, no issues about that. DWT, dead weight aboard will be if you have a W displacement, any condition, minus the light ship weight, that will give you DWT aboard. Light ship, weight of the cargo, weight of the ship, no fuel, no passengers, no cargo, no water. Light ship. इसका कितना है हिंज चिप का? ये तो बार बार फिगर होगा तुम्हारे न्यूमेरिकल पार्ट में. हिंज चिप का कितना है लाइट वेट? तो याद होगा. एक ये चीज आपको याद करनी ही है, because this will continue to figure, which is LBP. याद हो भी गई होगी, आप न्यूमेरिकल कर ही रहे हो, but to be very sure, LBP. This you have to remember. 143.16. ये तो आपको याद करना ही पड़ेगा. 143.16 is the LBP. बाकी ये चीज़ें चलती रहेंगी, नो प्रॉब्लम. ड्राफ्ट सर्विस में ये फिगर करेगा 19617 W of summer. ये किताब आपके पास होनी चाहिए, of course. Only then you will be able to start the numerical part. नहीं है तो कोई बात नहीं, we'll get it done. अच्छा, आपके सिलेबस में फेज 1 में इंक्लाइनिंग एक्सपेरिमेंट है क्या? Have you done that? Inclination?
No, sir.
नहीं, सिलेबस में है क्या? If you are aware. चलो कोई बात नहीं. ये सब तो नहीं चाहिए पड़ेंगे ड्राफ्ट सर्वे में, but you will definitely require what is called some particulars like drafts, summer draft, etc. ये चाहिए पड़ेंगे. Okay, you can. लाइट शिप हो गया क्रॉस टनेज नेट टनेज क्रॉस टनेज इंटरनल वॉल्यूम नेट टनेज टोटल वॉल्यूम minus the earning capacity, that is net tonnage. Now to start with, when you talk of draft survey, the drafts are read or marked at 6 points. 6 points, which is 6 pointed drafts. When you start the expression for draft survey, draft is measured at 6 points. 2 on the bow, port and starboard, port forward, starboard forward, 2 in the midship, port midship, starboard midship, and 2 at the stern, which is stern port side and stern draft starboard side. These are 6 drafts you require to start the corrections. Then you take the mean of all these drafts. Means forward port plus forward starboard divided by 2, then you have the forward draft. Port stern plus starboard stern divided by 2 will tell you stern draft. And of course, the midship ones are important to realize list also. So midship port plus midship starboard divided by 2 will tell you the midship draft, the mean draft midship. So that is how you begin. Firstly by reading 6-sided drafts. You can have draft surveys done for both, calculating loaded quantity, in which case you have done a draft survey on arrival load port, and then you have done a draft survey on departure load port. You can calculate loaded quantity, or it may be required for you to calculate quantity discharge, for which you will need out to carry a draft survey at arrival discharge port and then at departure draft discharge port. Then you can find out quantity cargo discharge. So we are looking at quantity of cargo discharge can be estimated by comparing W before and after discharge and making allowance, of course, for weights of non-cargo items, which is definitely going to involve what is called constant. So fore, aft, midships drafts read and means obtained. If there are 6-sided drafts you have read, which is recommended to read 6-sided drafts, then you have to obtain means of port, starboard, forward, aft and midship draft. अच्छा एक बात बताइए, जो आपके हाइड्रोस्टैटिक पार्टिकुलर अभी देखे भी थे हमने ये पूरा ये वाले हाइड्रोस्टैटिक पार्टिकुलर्स, इसमें जो ये ड्राफ्ट है ये वाले these drafts 7, 7.2, 7.4 एक्सेट्रा, ये कौन से ड्राफ्ट? हाइड्रोस्टैटिक, राइट. ये वाले सब हाइड्रोस्टैटिक ड्राफ्ट्स हैं. And what is actually, it is not a subject which we need to discuss, but what is hydrostatic draft? Draft at the center of rotation, LCF पे, the draft at the center of rotation, right? That is hydrostatic draft. Now my point is कि ये जो ड्राफ्ट है हाइड्रोस्टैटिक ड्राफ्ट ये हो गए COF पे, पर ये किस लेंथ के बीच में नापे गए? In which length of the vessel? What length is being considered? जी?
AF.
Between perpendicular.
Yes, LBP. It is always calculated on basis of LBP. In fact, अगर आप वहाँ पे थोड़ा सा सोचोगे तो स्टेबिलिटी के जितने भी फॉर्मूले हैं सब LBP पे हैं. LOA यूज नहीं होता स्टेबिलिटी में, राइट? LBP. LOA कौन यूज करता है? LOA, लेंथ ओवरऑल. अचीव सर, तुम तो इसको यूज नहीं करते हो बिकॉज नो फॉर्मूला फॉर स्टेबिलिटी इज इन्वॉल्विंग LOA.
Pilot card.
कौन?
सब बर्थ वगैरह जाने के लिए LOA यूज होएगा.
पायलट और
Pilot card में
pilot or harbor, they want to know LOA because they want to see whether the ship will fit in this space or not. So they will be interested in LOA. But as far as you are concerned, calculator or stability etc., you are not interested. I mean, LOA तो मान तो होना ही है, but you are not going to be involved with calculations involving LOA. You are more interested in LBP. तो अब अगर हम कह रहे हैं कि साहब आपके ड्राफ्ट मार्क्स जो है कहीं दाएं बाएं, they are not exactly at perpendiculars and all calculations are going to be involved with draft marks at perpendiculars. तो पहला स्टेप जो होगा to bring the draft marks to the perpendiculars irrespective of कहाँ painted है. That is the first step. Right? The first step to reduce, not reduce exactly, but to bring the draft marks wherever they are painted onto the perpendiculars by applying a correction. So that is step number 1. ये वाला. You need to apply one correction irrespective where the draft marks are painted to bring them to the perpendiculars. ठीक है जी? Exactly 4.5 perpendicular and the midpoint of the length between LBB, that is exact midship. Your first step is to bring the drafts to these points, although they may be painted somewhere else. They are painted somewhere else. I mean, practically also you just cannot mark on the perpendiculars. Also, as far as the numerical part is concerned, draft marks are always painted away from the perpendicular, forward or aft of the perpendiculars. As we are going through, you can also follow question number 105 as example. 105. Anybody with a book? I mean, you should be all having a book, but anybody can open out question number 105. Right? I was asking you because otherwise I have to scroll right down. Anybody can reach question 105?
ये हेडशिप पे ना सर, हेडशिप पे.
जी जी जी. हेडशिप क्वेश्चन नंबर 105 लोकेट कर सकते हैं आप. हेडशिप क्वेश्चन नंबर 105. right? Can you locate the question?
Yes, sir. Yes.
I'm very sure कि आप किताब तो है आपके पास आज. और एक बात याद रखिएगा प्लीज, अगर आज नहीं है कल ये टॉपिक कंटिन्यूड है, इसको किताब को जरूर लाइएगा. मतलब इट शुड बी हैंडी. में तो लाना पड़ता है, यहाँ तो आपको सिर्फ रेफर ही करनी है. तो ये क्वेश्चन लोकेट हो गया 105.
सर हाँ जी हो गया सर लोकेट.
ओके जी, एक मिनट देखिए जरा. आई वांट टू पॉइंट आउट समथिंग दैट वी कैन स्टार्ट डिस्कसिंग. ये देखिए, ड्राफ्ट मार्क्स इन दिस क्वेश्चन he has said draft marks are located 2 meter aft of FP, 4 meter forward of AP and 1 meter forward of midship. ये लिखा हुआ है इसमें. So draft marks are displaced, if I can use the word. They are not at the perpendicular, they are not exactly amidships, they are marked away from that, right? इस कैटेगरी में 2 मीटर आफ्ट ऑफ एफपी, 4 मीटर फॉरवर्ड ऑफ एपी, 1 मीटर फॉरवर्ड ऑफ मिडशिप, ऐसे लोकेटेड है, राइट? And this of course will happen with all questions. Although if somebody says if this line is not written, then of course you have to assume that draft marks are painted at the perpendiculars, जिसका चांस बहुत कम है, very little chance that you will make a simple question that no correction for perpendiculars is involved. तो उसका चांस कम है. You will always have some distance of draft marks. So this is the first step actually, correcting the drafts wherever they are painted to bring them to the perpendicular. That is the first step. Right. So let's see now how to correct the drafts wherever they are painted to the perpendiculars. अब ऐसा है कि hypothetical diagram, just to explain this point, let us say this is the forward part, this is the aft part, and then we say to see how this one is done. Let us say that this is the forward perpendicular marked on the mark तो है नहीं, but this is the FP. ये FP है, this FP, and I am again drawing a line to say this is exact midship, ये वाला. And with the rudder here somewhere, let us say AP is located here. तीनों मार्क हो गए, AP हो गया, FP हो गया और मिडशिप हो गया. राइट. अब ऐसा है कि let us say, as this question also says, draft marks are painted somewhere else, they are not on the perpendicular. तो ऐसा करते हैं, इसको इस कलर में यूज करते हैं कि एपी में आफ में ड्राफ्ट मार्क्स आर प्रिंटेड हियर, ड्राफ्ट मार्क्स आर प्रिंटेड हियर फॉर दी आफ पार्ट, ये मार्क है, ड्राफ्ट मार्क्स यहाँ पे प्रिंटेड है। प्रोवाइडेड ये हाइपोथेटिकल डायग्राम है कि रडर यहाँ पे है तभी प्रिंट होगा, नहीं तो इसको थोड़ा और इधर ले आना। चलो एनीवे टू अंडरस्टैंड, आफ्टर में ड्राफ्ट मार्क्स प्रिंटेड यहाँ पे, ये एलपी एपी है, यहाँ पे प्रिंटेड है, और मिडशिप में लेट अस से ड्राफ्ट मार्क्स प्रिंटेड यहाँ। फॉरवर्ड में हम कह रहे हैं कि ड्राफ्ट मार्क्स प्रिंटेड यहाँ पे है, ये ज़्यादा हो गया, चलो छोड़ दो, ड्राफ्ट मार्क्स यहाँ है। राइट। तो अब आप मेरे साथ थोड़ा इंटरेक्शन शुरू कीजिए। ये डिस्टेंस क्या है, यहाँ से लेके और यहाँ तक, ये डिस्टेंस को हम क्या बोलेंगे?
LBP सर,
एलबीपी
LBP।
सर।
एलबीपी।
एलबीपी, राइट, एब्सोल्युटली राइट। ये क्योंकि परपेंडिकुलर है, ये बन गया एलबीपी, राइट, दिस इज एलबीपी, बिल्कुल सही है। और आप मुझे ये बताओ, ऊपर वाला भी देख सकते हो आप, हाँ देख सकते हो, ये डिस्टेंस को क्या बोलोगे? नाम दे देते हैं, लेकिन फिलहाल मैं इसी डिस्टेंस की बात कर रहा हूँ, यहाँ से लेके,
डिस्टेंस बिटवीन ड्राफ्ट मार्क्स,
यहाँ से लेके और यहाँ
डिस्टेंस
तक,
बिटवीन ड्राफ्ट मार्क्स।
या क्या उसको हम शॉर्ट में बोलते हैं एलबीएम, लेंथ बिटवीन ड्राफ्ट मार्क्स,
हाँ जी,
जस्ट बाय
यस सर, बोल सकते हैं।
नॉमेनक्लेचर एलबीएम बोलते हैं इसको।
बोल लो सर।
ओके,
यस
तो ये बन गया एलबीएम या डिस्टेंस लेंथ बिटवीन मार्क्स, लेंथ बिटवीन मार्क्स इज आल्सो ओके, राइट। और फिर एक चीज और है कि ये हमने मार्क किया हुआ है, ये डिस्टेंस है ए, यहाँ से यहाँ तक, ये बन गया बी, यहाँ से यहाँ तक, इन दोनों के बीच में, और ये बन गया सी। ये हमने मालूम है हमें कि जहाँ ड्राफ्ट मार्क प्रिंटेड है वहाँ से लेके एपी तक, एफपी तक, और एग्जैक्ट मिडशिप में ये डिस्टेंस है ए, बी और सी, ये डिस्टेंस, राइट। वी आर लुकिंग एट दिस, ये और ये डिस्टेंस है बी बिटवीन एट मिडशिप, और ये डिस्टेंस यहाँ से यहाँ तक इज let us say a meters, and similarly here between this perpendicular and this draft mark, इसको हमने कह दिया c, राइट, ये वाला। अब ऐसा है कि अगेन टू स्टार्ट वी से दिस वेसल, हिंचे भी रखो, चलो, दिस वेसल इज ट्रिम्ड बाय स्टर्न, इज ट्रिम्ड बाय स्टर्न, अभी इस समय ट्रिम्ड बाय स्टर्न है, तो इसका जो वाटर लाइन है WL वो ऐसा कुछ होगा, वाटर लाइन something like this, exaggerated है of course, like this, right, ये WL है, trimmed by stern. So far so good.
ट्रिम बाय स्टर्न सर।
हाँ जी, trimmed by stern. वाटर लाइन जो है मैं ऐसे खींच रहा हूँ,
हाँ सर, बॉर्डर यस सर।
हाँ जी, क्या बोल रहे हैं?
आगे वाटर लाइन चाहिए ट्रिम बाय स्टर्न।
Trim by stern, right?
आगे
Draft
तो सीधा पानी।
WL कुछ ऐसी बनेगी ना अगर ट्रिम बाय स्टर्न है।
यस सर ऐसे ही बनेगी।
ओके वी गो फर्दर। आपने ड्राफ्ट पढ़ा कहाँ पे है? कहाँ पे पढ़ा है? फॉरवर्ड में कहाँ पे पढ़ा है? इस लाइन पे?
हाँ यस सर।
क्लास में सर, क्लास में।
ये वाली लाइन ना जहाँ मेरा कर्सर जा रहा है, इस लाइन में पढ़ा है। आपको चाहिए कहाँ पे है? या अगर बोल रहे हो तो मैं चुप कर जाता हूँ, फिर आप बोलो, नहीं तो फिर सब मिक्सअप हो जाएगा। आपको चाहिए कहाँ पे है? टू ब्रिंग इट टू परपेंडिकुलर, आपको चाहिए यहाँ पे, राइट? आप चाहते कहाँ हो ड्राफ्ट? एट दी परपेंडिकुलर, यहाँ पे। आपने पढ़ा कहाँ है? एट दी मार्क, एट दिस लाइन, एंड दिस इज सेपरेटेड बाय ए मीटर्स। लेकिन एनीवे आपने पढ़ा था यहाँ पे, चाहिए आपको यहाँ पे है, वो मार्क नहीं है ऑफकोर्स, पर आप यू वांटेड फॉर कैलकुलेशन कि ड्राफ्ट यहाँ पे हो एट दी एफपी। सिमिलरली अगर आप मिडशिप पे जाओ तो आपने पढ़ा है ड्राफ्ट यहाँ पे जो मार्क्ड है, पर आपको चाहिए एग्जैक्ट मिडशिप पे यहाँ। इसमें डिस्टेंस है बी मीटर्स। गोइंग फर्दर, आप में आपने पढ़ा यहाँ पे है, रेड ऑब्जर्व ड्राफ्ट की बात हो रही है, और आपको चाहिए यहाँ पे, और ये डिस्टेंस है सी मीटर्स, राइट? एलवीबी आपको पता है, एलवीबी यू नो, ये एलवीबी ये आपको मालूम है, ये वाला दिस यू नो। बट एलबीएम you can calculate, possible to calculate LBM, length between marks?
Yes, sir.
Okay, let's try. LBM हम कहते हैं LBM, इस वाले एग्जांपल में LBM कितना होगा in terms of LVP? In terms of LVP,
LBP minus.
LPP minus AC.
LVP you say ये माइनस है, राइट? तो आप यहाँ पे आ गए, माइनस है, और फिर नेक्स्ट
माइनस सी।
माइनस सी,
Minus.
करेक्ट? माइनस सी भी कर दो, this is LBM, right? This will be LBM. So this can be calculated easily because LVP hinge chip के लिए तो 143.16 है, और आपको ड्राफ्ट दिए हुए हैं कहाँ पे पेंटेड है। This is why I said, can you open out question number 105? 105 में can we work out this one? 105 में LVP तो वही रहेगी 143.16, right? उसके बाद इसमें I don't know, कोई आपको परेशानी हो रही है इसमें? ये तो सिंपल होना चाहिए। LVP तो 143.16। हाँ जी, नेक्स्ट
नहीं
ये
सर,
डिस्टेंस
परेशानी
कितना?
नहीं हो रही सर, हो गया सर ये आगे
अरे
से।
यार, मैं लिख रहा हूँ यार, अरे बोल दे तो मैं लिखता जाता हूँ ना। सारे सवाल तो वैसे भी नहीं करने, एक आधी करूंगा मैं। इसको मुझे ये बताइए कि ये कितना है LVP? ये ऐसे ही चलेगा इस केस में? ये तो मैंने बनाया था जो 105 है उसके में यही चल रहा है क्या? LVP माइनस ए माइनस सी, लोकेशन यही है।
2 मीटर आफ्ट ऑफ फॉरवर्ड परपेंडिकुलर, ठीक है।
ठीक है, तो इसको क्या बोले? 2 मीटर आफ्ट ऑफ फॉरवर्ड परपेंडिकुलर, तो इसको मैं 2 मीटर बोल दूं?
हाँ जी सर,
कौन सा?
-4
ये वाला, ये 4 मीटर लिखा है
4 मीटर लिखा है सर।
आफ्ट।
हाँ जी सर, 4 मीटर आफ्ट ऑफ परपेंडिकुलर,
तो
फॉरवर्ड
ये
ऑफ
ऐसे बनेगा, ये ऐसे बनेगा जी, ठीक है।
हाँ।
इसका कितना आएगा आंसर?
137.16।
137 पॉइंट समथिंग, 137 पॉइंट कितना बोल दी तुम? 16?
यस सर 16।
ओके जी, ये बना क्या LBM फॉर दिस क्वेश्चन, LBM फॉर दिस क्वेश्चन, राइट। अब बात हो रही है करेक्शन निकालने की, यू हैव टू फाइंड अ करेक्शन टू इंट्रोड्यूस। तो अब इसमें आप ऐसे समझो, ये जो आपने ड्राफ्ट पढ़े हैं, यू नो दीज ड्राफ्ट, ये क्वेश्चन में दिए रहते हैं कि ड्राफ्ट इतना था फॉरवर्ड में, हाफ में इतना, मिडशिप में इतना, दैट यू नो। इससे आपको ऑब्जर्व ट्रिम मिल जाएगी, ऑब्जर्व ट्रिम
हाँ जी सर
फॉरवर्ड
मिल
माइनस
जाएगा।
हाफ मिल जाएगी। तो वो ट्रिम को हम बोलते हैं टी, अभी के लिए टी बोलते हैं, टी। तो वो ट्रिम आपकी निकल आएगी क्वेश्चन में, ऑब्जर्व ट्रिम, ऑब्जर्व ट्रिम टी है। ये ट्रिम कहाँ पे एप्लीकेबल हो रही है? ट्रिम,
सर ये तो
ये जो ट्रिम आपने निकाल ली ऑब्जर्व ड्राफ्ट से, ये कहाँ, किस लेंथ पे एप्लीकेबल हो रही है?
LBM।
LBM, राइट, लीमा ब्रावो माइक, करेक्ट। तो ये पूरी ट्रिम जो है एप्लीकेबल हो रही है LBM पे, या इसको एक और तरीके से लिख सकते हैं, नो इशू। LBM पे, लेंथ बिटवीन मार्क्स पे एप्लीकेबल ट्रिम जो है वो है T, LBM पे। पूरा नहीं लिख रहा हूँ मैं, बहुत टाइम लगेगा। एप्लीकेबल ट्रिम जो है वो है T, ऑब्जर्व ट्रिम, राइट, फॉरवर्ड और आफ्टर का डिफरेंस। तो ये जो डिफरेंस है ए, ये वाला, बाय यूनिटरी मेथड ए पे कितने लगेगी? ए पे LBM पे T है, तो ए पे कितनी है? ए इज द डिस्टेंस बिटवीन ड्राफ्ट
T by
मार्क्स और, सॉरी, T
divided by LBM into A.
करेक्ट, डिवाइड बाय LBM इनटू ए, राइट। ये बनेगा ए पे ट्रिम एप्लीकेबल, जो ये डिस्टेंस है, ये डिस्टेंस है। अच्छा, आपने ड्राफ्ट यहाँ पढ़ा था और आपको चाहिए यहाँ पे है, तो ये जो ड्राफ्ट है ये यहाँ पे, ये ज़्यादा होगा कि कम होगा? वाटर लाइन से निकलेगा ये, वाटर लाइन तो चाहिए बाय स्टर्न, तो आपने पढ़ा यहाँ पे, चाहिए यहाँ पे, तो क्या होगा? ये ड्राफ्ट जो आपने पढ़ा है यहाँ पे, जो करेक्शन आप निकाल रहे हैं वो इस फॉर्मूले से निकाल रहे हैं, करेक्शन, ए करेक्शन। ये करेक्शन जो है क्या बोलेगा आपको? ये जो ड्राफ्ट आपने यहाँ पढ़ा है चाहिए आपको यहाँ पे, तो ये ड्राफ्ट यहाँ पे कम होगा इस ड्राफ्ट से या ज़्यादा होगा?
कम होगा।
कम होगा, बिकॉज ट्रिम्ड बाय स्टर्न है, रिमेंबर, बिकॉज ट्रिम्ड बाय स्टर्न है, तो ट्रिम्ड बाय स्टर्न है, इस केस में कम होगा। सो व्हाट वी आर सेइंग इज कि आप एक करेक्शन निकाल रहे हो इस फॉर्मूले से, लेट अस से ए करेक्शन, दिस इज गोइंग टू बी नेगेटिव इन आवर एग्जांपल हियर, दिस इज गोइंग टू बी नेगेटिव इन दिस एग्जांपल, राइट। ये आप निकाल लोगे ए करेक्शन, इसको आप कहाँ पे लगाओगे? एट द ड्राफ्ट यू हैव रेड फॉरवर्ड, एंड टू फाइंड आउट कि करेक्शन ऐड होना है या सब्ट्रैक्ट होना है, ये डायग्राम आपको हर क्वेश्चन में बनाना पड़ेगा। इतना ज़्यादा एक्सटेंसिव नहीं, बट यू नीड टू ड्रॉ रफ डायग्राम टू नो कि आपकी वाटर लाइन कैसे है, और जो करेक्शन आप निकाल रहे हो वो परपेंडिकुलर पे लगना है प्लस में या माइनस में। यू गेट माई पॉइंट? क्योंकि ये हर बार अलग होगा, अलग होगा। हम तो 105 ले रहे हैं, 106 में कुछ और होगा, 107 में कुछ और होगा, इट विल बी ऑलवेज डिफरेंट। एनीवे, उससे मतलब नहीं है। द पॉइंट रिमेन्स कि आपने करेक्शन निकालना है ए, उसको आपने इस केस में लगाना है माइनस, टू द ड्राफ्ट एट द फॉरवर्ड। और ये रिमेंबर करना कि जो ड्राफ्ट आप लोगे, अगर ये 6 साइडेड ड्राफ्ट है, तो ये ड्राफ्ट जो है जिसमें आपने करेक्शन लगाना है, दिस विल बी मीन ड्राफ्ट ऑफ द फॉरवर्ड ड्राफ्ट। Forward draft forward plus starboard draft forward divided by 2, that is the draft you will take and apply the correction A. I am stopping just for a minute ताकि आप मुझे बताओ यहाँ तक ठीक है? बताओ, क्योंकि आज तो हो ही नहीं सकता, नहीं हो पाएगा। बताइए मुझे, आर यू ओके टिल नाउ?
Yes, sir.
Okay, okay. So what we have done so far is we have calculated LBM, we have calculated the correction A, to be applied, minus in this case to the forward drafts. But forward drafts is clearly understood that they are going to be, let us say, forward port plus forward starboard divided by 2. ये बनेगा आपका forward draft. If there are 600 drafts, then this is going to be the mean forward draft. अब बात रहेगी ट्रिम की, टी की. तो आपने निकाला ये ड्राफ्ट, फॉरवर्ड पोर्ट फॉरवर्ड स्टारबोर्ड डिवाइड बाय 2, तो फॉरवर्ड ड्राफ्ट आ गया. देन यू कैलकुलेट हाफ ड्राफ्ट लाइक दिस, हाफ पोर्ट प्लस हाफ स्टारबोर्ड डिवाइड बाय 2. उसके बीच का डिफरेंस विल बी टी एंड यू विल नेम दैट एज ऑब्जर्व ट्रिम. ठीक है जी. इन दोनों का डिफरेंस will tell you what is called observed trend. Right? So what you can do is, can you follow the question 105 just till this part, just till finding the correction to observe draft, correction to observe mid draft. ये भी हो सकता है, mid draft को भी correction लगा दो. मीन यहाँ तक है, बस सिर्फ यहाँ तक आइए आप, up till here only. Right? Do follow this question up till this step and then we will continue. Do not go to this. If you want, you can go, but if you are getting confused, stop it. And we have to, or you follow up till this point. You can see the shade screen, right? तो इसको जरा एक बार आप देखिए, follow it up, and then we can discuss further.
Okay, sir.
Okay, जी. This is just the beginning. You are well aware. You need to have 6-7 steps to come to a conclusion. This is step 1. और कल जब मिलेंगे, I don't know what time, जो भी क्लास का टाइम है, you can raise any doubt till this step. Right?
Okay, sir.
Okay, जी. So far so good. So I got another class. I think you also have one. But what we are going to do is, for the time being, we stop and we meet again. Design class. I think tomorrow itself. Do respond to this chat box. That will take care of today's session and we'll meet again.